Okay, let us start the class now. And today the topic is current electricity. And what we'll cover here? We'll cover ohmic and non-ohmic resistor, then some conducting material for specific use. We'll see one by one. And at last, we'll come to know about the electric cell. Okay, its construction and working of it. Fine. Let us move one by one. First is ohmic resistor and non-ohmic resistor. What is ohmic resistor? Okay, it is here given also. The conductors which obey Ohm's law are called ohmic resistor. Means what? Any conductor which follows Ohm's law will call as ohmic resistor. Means what? As per Ohm's law, when the voltage is increasing, accordingly the current is also increasing and vice versa. Means once current is increasing, voltage is increasing, means the ratio of voltage and current will be always equal, always same. That we call the resistance. We can understand it like this. Let us suppose, this is the comparison between the voltage and current. Fine. Current has been taken on the y-axis and voltage on the x-axis here. Okay. Let us suppose the current is, how the current will increase when voltage is increasing in the circuit here. We can divide this voltage similarly on this current line also. We can see when the voltage is increasing, the current is also increasing in the same ratio. Like this, we can take like this. Okay, we can see. So the ratio of this one V and I will be always equal or always same, and that is the value of resistance. Okay, so constant ratio, that is V by R, that is called the resistance of conductor. We can say here constant ratio, that is V by I is equal to R. And what is this R? R is resistance of this conductor or wire, we can say. This is the resistance of wire or conductor. So in case of ohmic resistor, this rule will be followed always. Means what? Once the ratio of voltage and current is taken, it will be always constant, and that will give the value of resistance, provided all the physical condition and even the temperature is maintained constant. That's why we have taken some of the metallic conductors like silver, aluminium, copper, iron, nichrome, sulfuric acid also. It also follows the Ohm's law. Okay, this is the region the aluminum or copper is mostly used in our electrical circuits because it is having the same properties. It is easily available also. The energy losses due to heat is very low in this case, and most importantly, compared to other conductors, its cost is less. This is the reason aluminum and copper are mostly used in the electrical circuits. Okay, this is what about the ohmic resistor. Some figure also shown here. See, is the copper, this is aluminum, copper, aluminum, and this is the sulfuric acid H2SO4 being liquid. This is the good conductor of electricity and it obeys the Ohm's law. Fine. Now let us see the non-ohmic resistor. Non-ohmic resistor, just it is opposite of the ohmic resistor. It doesn't follow, it doesn't obey the Ohm's law. Fine. What are the examples? Some examples are also given here. In case of light emitting diode, then solar system, diode and transistor pictures are also available to see. This is light emitting diode, this is diode, this is a symbol of diode, this is solar cell and transistor. In all these cases, the Ohm's law is not obeyed. Means when the voltage is increasing, it is not necessary in the same ratio current will also increase or decrease. It means it doesn't obey the law of Ohm's law. So in this case, we can say these are the non-ohmic resistor. Okay, fine. Let's move next. Here we will study about some of the materials which is used for special task, we can say. For electrical connection and power transmission, what we are using generally aluminum or copper. Aluminum is less costly compared to copper. See, power is generated at the power station that is situated at a remote area from the cities or villages, you can say. We have to transmit that power through the transmission tower or cables or wires to the respective cities for the domestic use or from the industrial use. So it needs a large quantity of conductors like aluminum because it is less costly and comparatively it gives the least loss due to heat. So these are the properties of such conductors like copper and aluminum, which is used for electrical connections and power transmission, having less resistance and least power loss also due to heat. Silver is mostly not used because it is costly affairs. See, okay, for standard resistor, for making a resistor or varying the resistance value, these are the materials used, that is magnet and constantin. And then what is the property? Why these are used for making the standard resistor? Because it is having the high resistance and due to temperature it doesn't vary. There is very less variation in the resistance value in case of these magnet and constantin. This is the reason it is used for standard resistor. Okay, let us see some more. For fuse hour, we know this is used for the safety purpose. It is safety device for the electrical circuits. Because then what is the property of this fuse wire? Because its melting point is very low and its specific resistance is very high. Okay, it is used along with the copper and aluminum because mostly these are the conductors used for in the electrical circuits. So fuse is also used in that electrical circuits for safety purpose. Okay, due to low melting point, mostly tin and lead are used for this purpose for making the fuses. Next comes filament of electric bulb. We know the filament of the bulb is made of tungsten. So what is the property of this tungsten? Because its melting point is very high. It doesn't melt at low temperature. Okay, even it is given temperature 3380 degrees Celsius. It is the melting point. And such situation doesn't come where this bulb will use, because at low temperature it starts glowing and it starts giving light. Okay, so what is the property of such material? Because it is having high melting point and resistivity is very low. So this is applicable in case of tungsten. Fine. Next, heating element in electric heater, electric iron and geyser oven. Generally it is, these are the domestic appliances, electrical appliances it is used. And for heating element, this material, what is called nichrome, is used. Then why nichrome is used? Because it is having the property, its specific resistance and melting point both are very high, and this is required in case of these appliances. Which one? Electric heater, iron, geyser and oven. Means when temperature is increased, it resistance also gets increased. So this is the property of nichrome. That's why it is used for these appliances. Fine. Okay. Now we have to know what is EMF. That is electromotive force. Okay. Very, very important. Okay. Just let us go once more. The electric cell maintains a constant difference in potential between the two conductors, that is called electrodes also, by a chemical reaction to obtain a continuous flow of charge between them. Okay, you might have not understood it, this one. Just I am going to explain the internal construction and working of this electric cell, then it will be more clear. Fine. The same electric cell is shown here. This is the container. You can say this is the container. Okay. These are having two terminals. You can see here, red is positive terminal, always shown. Okay. And this one black is negative terminal. Okay. And inside, that is electrolyte is there. Electrolyte, that is liquid, and mostly H2SO4. Dilute. Dilute means water is mixed in sulfuric acid. It is used as electrolyte in case of electric cell. Okay. So let us know in detail its construction and working of this simple cell. Okay, because it is already given here the working of cells, but I will explain here. You'll come to know the same thing is written on that page. Fine. See what I told. This is the container. This is the container. It may be metallic container. Okay. Electrolyte. Electrolyte. This is dilute H2SO4. Sulfuric acid. Fine. This is called electrode or conductor. We can say. So this one is, this electrode is made of copper. Fine. Cu. Okay. And this electrode or conductor, this is made of zinc. Zinc. Okay. Made of zinc. Okay. And this is, as I told, this is sulfuric acid. Fine. Then what is simple cell? Simple electric cell. We can say this is electric cell. Electric cell. It it converts chemical energy chemical energy into electrical energy. Okay, this is the basic purpose of this cell. Okay, and how does it do? How it is converting the chemical energy into electrical energy? Let us see. I'm going to explain the same thing here. Okay, copper. Just we have to remember, copper is having, it is having the property is less reactive. This is less reactive here, and this is more reactive. Zinc is more reactive here. See, these two plates are partially dipped, partially immersed here, not fully. You can see here some portion is also visible. Okay, so what is happening here? Because these two plates are immersed in this liquid dilute H2SO4. Okay, due to more reactive property of this zinc, what is happening, that zinc ions are separated from this zinc plate. Okay, zinc ions are separated here from this plate. Okay, so what is happening, and this dilute H2O4, this is also broken. This is broken into two ions, positive ions and negative ions. What is positive ions here? Hydrogen ions are positive and sulfate ions are negative. Okay, fine. Then what is happening here? We'll see here. The positive ions means, first let's know what is ions. Ions means what? What the meaning of ions? Positive ions and negative ions. Ions is also, we can say, this is atom having uneven number of electrons and protons. As we know, in case of any atom whatever numbers of protons are there in the nucleus, the same number of electrons are available in that that atom which is revolving around the nucleus. Okay, fine. Electron means number of electrons should be equal to the number of protons. But in case of, once we are telling ions, means what? It is the number of electrons are not equal. This is not even. So what is happening? If the number of protons are more, means it is positively charged. And on the other hand, once we are telling the negative ions, means what? The number of electrons are more there. Electrons is negatively charged. So this is also charged, you can say. This hydrogen ions is charged and sulfate ions is also charged. So now what is happening? This hydrogen ions is being attracted by the less reactive conductor copper, and it is deposited. These hydrogen ions are deposited on this plate, copper plate. Then it is causing the electrons to remove from this plate. Means electrons are being removed, and this one positive ions, that is hydrogen ions, are getting deposited on this copper plate. Fine. Okay, let us see then what is happening on this plate, zinc plate. The zinc which is coming in contact with the sulfuric acids, and it is making the zinc ion, that is positive ions, and it gets combined with the sulfate ions, so it makes the zinc sulfate. Okay, then it means more number of positive ions are coming out from this zinc plate, means the number of negative ions are getting deposited available on this zinc plate. It means having the number of electrons are getting increased on this zinc plate. It means number of electrons means negative charge, because electrons means it is having charge. So this zinc plate becomes more negative due to presence of more and more electrons, and on the other hand, the copper plate becomes more positive due to loss of electrons, or you can say presence of protons. So the copper plate becomes positively charged, and this zinc plate becomes negatively charged. That's why this plate is called anode, and this is called cathode. This is called cathode. Okay, fine. It means for outside, when load is connected across these plates in external circuits, current will flow from anode to cathode, means conventional current from in this direction, like this. Conventional current will flow in this direction from positive to negative. But in case of internal, here, due to flow of electrons, this will be conducted, means electrons is moving from from positive to negative, positive to negative, from this side to these sides. So electronics current, we can say electronics current is flowing. Electronics current. Electronics means due to electron. Electronics current is flowing inside the flowing in, inside the cell, that is in the electrolyte, that is in the electrolyte. So this way, this potential difference is created between the two plates due to such chemical reaction or chemical effect. Chemical effect means due to presence of dilute sulfuric acid. Such things are happening, and this cell can be used as a storage device, storage power device for the future use. So this is all about the working of simple electric cell. The same thing is here written. So you can say copper plate, this is anode, zinc plate, this is cathode. As I explained, electrolyte, what is here? H2SO4. Chemical reaction, what is happening? Electrons are removed from the copper plate, fine, and deposited to zinc plate. We have already discussed. Zinc becomes negative and copper becomes positive. Dilute H2SO4 breaks into positive ions. We have already discussed here, and negative ions. H2SO4 already discussed here. Hydrogen ions gains electrons, very good, from copper and make it positive. Okay. On the other hand, this one SO4 sulfate ions, okay, ions gives more electrons to zinc plate. Fine. So potential difference is created at both the electrons. This is the all about the electric cell. Okay. Okay. Thank you.